Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at transforming expressions of this type. Namely, we're going to write them either like this or like this. So when we're doing this number r out the front, which means radius, can be easily calculated using Pythagoras. It's just the square root of a squared plus b squared. So if I want to write this in one of these forms, I'll just pick this one. Either one wouldn't matter. First thing I'm going to do is calculate r. So r will just be the square root of 4 squared plus negative 4 root 3 squared. So of course 4 squared is 16. This squared is 48. So r will be the square root of 64/8. We always take a positive value here for r. We ignore the negative square root. So now what we do is we put this 8 out the front and we divide each term by 8. So we get half. 4 divided by 8 is a half cos x. And minus 4 root 3 over 8 is just minus root 3 on 2. Okay, now I've got something that's looking a bit like what we get when we expand using the angle sum or difference formula. If we take r to be this, you always end up with these two such that this squared plus this squared equals 1. So we can write these numbers as sine alpha or cos alpha. So I have a half. I can write it as sine alpha or cos alpha. If I want to write it in this form, this needs to be a sine. And if I write it in this form, this needs to be a cos. So because I said I was going to write it in this form, I'm just going to calculate the sine inverse of a half. So I can just take the acute angle here, and that will be 30 degrees or pi on 6 radians. Now, because of the way that I took out r, that means that this will also be cos pi on 6. We know cos pi on 6 is root 3 on 2. So I can rewrite this as 8 sine pi on 6 instead of a half, and so on. So hopefully you recognize this is what we would get if we expanded 8 of sine. Now, because we have sine of pi on 6 first, that's written first. So it'll be pi on 6 minus x. Okay, now we could just as easily have written it as minus 8 sine of x minus pi on 6. Either way is fine. So we've written it now in the form that we wanted to, and it turns out this is very useful for graphing and solving equations. Let's look at a graphing example. So graphing a function like this is not easy because it's not immediately obvious what is the amplitude, phase shift, etc. So I'm going to write this in one of the forms we saw on the previous slide. Now when we're graphing, it's easier to write it in the form cos of something. So I'm going to write this as r cos of x plus or minus some value alpha. It's just easier with cos because you can find the first peak a lot easier with cos than with sine. So let's go ahead and do this. So in this case, r is just going to be the square root of 1 squared plus 1 squared because it's 1 sine x minus 1 cos x. So I'm going to take out a factor of root 2. So I have root 2 out the front of 1 on root 2 sine x, and then similarly for the second term. Now we know that sine inverse and cos inverse of 1 on root 2 give us pi on 4. So I can write it like this. Now you're probably thinking, okay, this is almost but not quite the expansion of cos of x plus pi on 4. In cos of x plus pi on 4, the coses and sines are switched around. So what we can do is we can make this a minus root 2. We put a minus here and a plus there. This becomes negative root 2 cos of x plus pi on 4. So we can go ahead and graph this because it's easy to find now the amplitude, phase shift and everything. So the amplitude here is root 2. The midline D is 0 because there is nothing written out here. The period is 2 pi divided by 1, because b here, the number in front of it, is 1. And we can find that the first peak easily. So for cos, the first peak is just the negative of that. So there would normally be a peak at negative pi on 4. Now what happens is when you have a negative out the front here, it just switch around the peaks and the troughs. So this will actually have a trough at x equals minus pi on 4. So with this, we have enough to graph. So because the midline 0 and amplitude's root 2, the max value will be root 2 and the minimum value will be negative root 2. Now there's a trough at minus pi on 4. Because the period's 2 pi, the next trough will be at minus pi on 4 plus 2 pi, which is 7 pi on 4. So that's over here. There will be a trough. And we know that if the period's 2 pi, the distance between peaks and trough will be half of that, so it will be pi. So 7 pi on 4 minus pi gives 3 pi on 4. There will be a peak here. So the graph is just going to look like this. It's going to start down here, come up, goes up and down forever. All right, there we are. We have graphed with the aid of transformations. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.